Welcome back to the fifth part of my video series about creating a simple game in Unity. This time I'm excited to show you the AI I made for the cars. Do you remember how in the first video I said that the game would probably have only a multiplayer mode, because I wasn't sure if I would be able to create AI for the cars? Funny thing is, I just created a single player mode, but I still have the multiplayer left to do. Right now, you're watching a match where I play against this new AI. As you can see, it is not too tough, but certainly demanding. Okay, that's all from me. My voice assistant will tell you how it all works.
Car's AI operates in two modes. On the opponent's half, it shifts into attack mode, trying to position itself for the best shot at the goal. When the ball is on its half, its objective is clear: kick the ball out of danger. Let's see how this works. Here's a scene that the author created for testing AI. There's a ball in the air and a ramp for the ball to roll down. First, the easier scenario. The ball rolls down towards a goal, and the AI car tries to hit it in. You can see the ball's predicted path in yellow, calculated by the ball predictor component. The car's planned route is visible in white. The car uses an algorithm called Dubins Path to pick the best route to reach the ball. The car's AI calculates an approximate time when it will be able to reach the ball and takes the predicted position of the ball at that moment as a target position. Additionally, it checks when the ball will be on the ground and ensures it will hit it then. Now the author will change things a bit. He will turn the ramp to direct the ball away from the goal. Observe how the car changes its path to still try and hit the ball towards the goal. Enough of talking. Now the author will show you how it works in action. You'll see the ball's predicted path and the AI's car planned route. Now it's time for some theory. In the game for AI, the author uses the Dubins Path algorithm but didn't create it himself. He used the solution prepared by Habrador, which is available on GitHub. His solution is bigger and more advanced, but the author only uses the part located in the Dubins Paths directory. The Dubins Path algorithm is a method used for finding the shortest path between 2 points in a plane. To calculate the path besides 2 points, it also takes into account the starting and ending directions, or headings. So at the end of the path, the car will be facing the ball. For that reason, this algorithm is particularly useful for vehicles like cars or robots that can only move forward and change direction gradually, making sharp turns impossible. But how does it do it? Calculated path typically consists of 3 segments, 2 circular arcs and a straight line. The arcs represent the car turning, and the straight line represents the car moving forward without turning. The algorithm chooses these segments in such a way that the total path length is minimized, allowing the AI to reach the ball in the quickest and most efficient manner possible. By using this algorithm, the AI car can navigate smoothly and realistically, mimicking how an actual car would maneuver to reach a target while respecting its physical limitations of movement. But how does it all work? First, we'll discuss the ball predictor component. It calculates the future position of the ball based on physics simulation. At the start method, it creates a virtual scene to which objects from the simulated obstacles component are added, in this case, a simplified collider of the arena and the ball. Since it is a simplified arena collider, the simulation will slightly differ from real colliders, but this will speed up the calculations. The ball position prediction will cover 10 seconds into the future. This should be enough to determine the optimal route for the AI car. To save resources, the data will be updated every 3 seconds. Simulating the ball's position for the entire 10 seconds is a significant CPU load, so it's better not to do it all at once. Therefore, the author has divided it into parts of 7 frames at once. So to calculate the full 10 seconds of simulation, it takes 71 frames. Additionally, he checks whether the ball touches the ground at any moment so that the AI aims for the position when the ball will be on the ground. A small disclaimer: in the video, the author recalculates ball predictions every second, but later he realized it might be too short. When the game runs at 30 frames per second, it will take over 2 seconds to predict all ball positions. So he changed it to update every 3 seconds, and it works fine. After calculating all positions, the data are transferred from the raw predicted points variable to predicted points, from where they can be accessed by the AI. Now let's see how the car AI uses this data. To calculate the ball's position, it's necessary to know how long it will take for the car to reach that position, so we need to know the general length of the route to the ball. The author solved this by first checking the distance to the ball in a straight line. Then, assuming the car's speed is 100 kilometers per hour, he calculates the travel time. Next, he gets the position of the ball at that time from Ball Predictor, and then, using the Dubins Path algorithm, calculates the car's route. This is an approximate path. To calculate a more precise one, he takes information about its overall length and, once again, recalculates the travel time, retrieves the ball's position, and recalculates the car's route using the Dubins Path. Now the car has a route that should lead the AI to score a goal. This is the whole logic. Not very intelligent, but still challenging for the player. Of course, this algorithm has some issues. For example, the calculated route does not take obstacles into account, so it may plan a route that leads through a wall. However, the author will not refine it for now. This solution should suffice for casual play. And that's all. Thank you for watching. In the next video, the author will try to create a multiplayer mode.